If you've ever driven a Tesla, I imagine you have. I mean, the acceleration is incredible, right?
Oh yeah.
So yeah, but again, the problem of trying to store electricity, as a and give and do that in a way that is comparable to the way that energy is stored in gasoline is just really difficult. And physically we'll never quite reach the energy density of gasoline in a battery. It's just not possible unless we invent new elements in the periodic table. It's not going to happen. So we're limited there. The
So
charging
so
time
so I so let me interrupt
is
you.
something that
So
is limited by physics, right? So
but
I guess that's why is like we're running up against over time. We're running closer and closer to these limits, these hard physical limits on what batteries can do. And so each increment of improvement gets harder and harder. That's why, it's still, like I said, it took 10 years to develop the first lithium ion battery. And every new iteration of the lithium ion battery since then still takes 10 years to develop, because each iteration gets harder and harder as we get up closer to those physical limits. So that's why it's so batteries are getting better, but there's just limits to how good they can be, right?
but what are those limits? I mean, you're a material science guy, so tell me why batteries still
Yeah.
suck. Why is it? What is it about the battery itself that we just haven't been able to improve? What is it about the thing of
Yeah.
that thing that well, you said the limits of physics. Well, how do you explain that?
Yeah, yeah. Well, I mean, and you talk a lot about power density. I know you have a whole talk about that, but really it's two things. One is how much energy can you get into the battery, right? So that's limited by the materials that you can use, right? There's only so many electricity that you can pump into a battery and store it there in the form of chemical bonds, right? So that's the
There are
limit
only a
of
few,
energy.
and to follow up on your idea on the periodic table, there are only a few metals that are efficient at that or that are useful for that
Right.
process, right? So
Mm-hmm.
as
Right.
Sadoway says, you've got to, what did he call it, an assay, right? You can assay the periodic table to see which ones are the ones that are likely to be good. So you have a
Yeah.
limited number of elements that you can work with to make the battery, right? And it's a
Mm-hmm.
very few specific metals, and lithium is one of them, right? And so that's
Right. I mean, and lithium's the lightest metal in the periodic table, so we're not going to get any lighter than that. Now, we might can use like sodium or aluminum that have some other properties that make them better. They're more stable, um, and particularly aluminum. You can maybe charge your battery faster, but you're not going to get any lighter or more energy dense than what you get from lithium. Like that's it, right?
gotcha.
It's the lightest element out there, and so yeah, there's only so many electrons that you can store in a lithium compound, right? So that's the energy density limit, and then also the power density limit is how fast can you pull those out, right? So you can only break bonds so quickly and pull electricity out so quickly, or put it in, right?
Right.
So and oftentimes those two things are counter to each other. If you can store more energy in a battery, but a lot of times in order to do that, you have to give up charging time, because you have to make the battery thicker. You have to change the design. There's just those two things, kind of energy density and power density, kind of work against each other. And yeah, and so again, like, we can make nowadays batteries that are more energy dense than what exists in commercial developed, right? I can go in the lab and make one, right? But it's not going to charge. It's going to have to charge really slow,
Right.
right? Or I can make a battery that charges really fast. Heck, a capacitor, which is just two metal plates basically that hold charge between them. We use capacitors in electric cars nowadays to help accelerate, to get that real quick charge out of them, right?
Right. Right.
Like those are really good at charging and discharging really quick, but again, they don't hold a lot of energy.